Hello, everybody. Let's see. I think I'd like to start off with showing you guys the key to Quiz 10, and then I'm also going to add another video that's just like a general example. How might we use stats and probability, practically speaking? Okay, so let's start off with quiz. It says 9, but it's really 10. Um, let's go back over here. Oh, okay. All right. So number one. Um, what do we have here? Yeah, so here's a table, and you can see this table in your book as well. But here's, so across the top, we have the possibilities for die one and the possibilities, and down the side, die two there. And then the sums fill out the grid. And so this is kind of a nice, kind of an efficient way to see that there are indeed 6 ways to get a sum of 7 going down the diagonal there. Um, Interesting patterns are emerging, um, the sums tend to follow down the diagonals in kind of an interesting way. Um, 12 and 2 have each just one combination, and it fills out a 6 by 6 grid, so you know that the total possibilities are 36, 6 by 6. And so we get 1 6 for the probability there. Six ways to get it out of 36. Okay. For number 2, I did this 2 ways, and these are not the only 2 ways to get an estimate for this. Okay. So 10 classes in the freshman year, right? So what's the probability you have no matches with a size of 23, the average class size, and the probabilities of that is about 50%. So sort of first brush, assuming same class size for each class, about 10 classes, you would have 0.5 to the 10th power, which is 1 in 1028 or so, about 1 in 1,000. So what are my assumptions for this problem? My assumptions are that freshman class sizes represent average class size. I don't know about that. And that 10 classes in the freshman year, which I'm pretty comfortable with. Okay, so let's try it again. And this time I'm going to alter the assumptions a little bit, because in general, freshmen have slightly larger classes. In general, lower level classes are smaller. And I also added the assumption, so I added 2 assumptions here. Your average is a little bit bigger for any class, and you're going to have at least 2 large classes, about 75. So this leads to a more complicated formula. Probability of no match with 30 to the 8th power times probability of no match with 75 to the 2nd power. And those probabilities you can just find in the worksheet, the Google Sheets we did for that. Yeah. Okay. So yeah, that's number 2. Number 3, sort of a standard normal curve problem. You just look up mean and a standard deviation for women's heights and run with it, right? And what we have here is that someone that's 7 feet tall is lots of SDs away from the mean for height. That's that. It's very unlikely. That's what you can say about that. Okay. The rain in April problem. I realized that half of my sentence disappeared when I was typing this up. Yeah, anyway, it was supposed to be a 2-part thing. The idea was, what's the chance you have no rain in the first week of April? So 7 days straight, no rain. So if you do that, we know the probability of a rainy day from, what's that website called? No, okay. Yeah, this possibly helpful weather site I posted on the website. Okay, yeah. So it says somewhere between 32 and 34. Call it 33. It seems a great way if it's a great between value to pick. So I picked 34% chance of that any day in April is rainy. So the chance of no rain then is 66%. And I want 7 days straight of that. So that's just 0.66 to the 7th power. Oh, and if you do that, Yeah, that's whoops. That's 0.055 or about 5.5%. Okay. Yeah, so that's the first part of number 4. Um, the second part of number 4 is to say, how much rain would I have to get for it to be very unusual for Aprils? So in this case, we're going to assume relatively normal distribution, and we're going to take advantage of this standard deviation approximation, range divided by 4. If you look back at the website, somewhere between 34 and 32% of days in April are rainy on average. So the difference of that is 2%. 2% divided by 4 is 0.5%. And now I just have to figure out how many standard deviations above the norm do I have to be for 95% of Aprils to be below me. And so I'm going to pop open the percentile calculator here. The percentile calculator here. Weird. Go back. Percentile calculator. And I'm going to say, give me on the standard normal, so that's a mean of 0 and a standard deviation of 1. How many standard deviations? So in other words, if my standard deviation is 1, and I ask how many standard deviations do I have to be above 95% of my data, there it is, 1.645-ish. Okay, so yeah, so I need to be 1.645 standard deviations away. I've calculated my standard deviation to be 0.5%. So 1.645 of those is 0.8225%. So that means, so here's kind of the next part. So that means I have to be that percent above the mean. So 33% plus 0.8225%. So percent rainy would need to be 33.8225%. That's how it goes, guys. I'm going to be coming back at you with another short video. I'm going to do a real practical problem. It's going to be about making nails in a factory and packing defects. Hope y'all have a wonderful day. How do I turn it off?